Let us talk about the CSIR NET question paper. Here the question is a conducting circular disc of radius r. Here is circular disc of radius r and the resistivity rho rotates with an angular velocity omega in a magnetic field B perpendicular to it. Here a voltmeter is connected in shown in figure. So, assuming its initial resistance to be infinite, the reading on the voltmeter is what? So, according to the Faraday's law of induction, the electromotive force EMF can be written as phi equals to minus ddt of B dot ds. This B is the magnetic field vector and ds is the surface area, where B is the magnetic field vector and ds is the area. So this phi can be written as minus of ddt of integration over B dot ds. So phi equals to, here B is constant, so B is taken out from the integration, minus V ddt of integration over ds. Here this B into ddt of ds means here A into ddt of cos omega t, where A is equals to A cos omega t. So here we can write this minus B A into ddt of cos omega t. So this equals to minus B, this is the ddt of cos omega t. So this means ddt of cos is minus sin omega t, sin omega t with a minus sign. So this is minus B A into omega into minus sin omega t, where A is equals to area, this is the pi r square. So this equals to B pi r square omega sin omega t. So the reading on the voltmeter depends on depends on B, R and omega. This is the magnetic field, R is the radius and omega is the angular velocity. This voltmeter depends on magnetic field, radius and the angular velocity. Here A is the area of disc. So here the answer option is correct for this reading depends on B, R and omega but not on rho. This is the option B. So the option B is correct for this question. So if you have any query regarding this question, you can comment on the comment box and you can WhatsApp us in this number. This is 98367 93076. You can WhatsApp us in this number. This is 98367 93076. So that's all for today.